What is programming? The act of writing computer programs is called computer programming. Example: Java, C, C++, Python, PHP, Perl, Ruby. The beginning of the programming era spans a period of over 2 centuries. The recent advances that led to the development of sophisticated programming languages and systems were preceded by the work that opened the door to what we use today. The first attempt to devise anything programming related date back to the 19th century. In 1843, Charles Babbage developed the concept of programming and actually devised the first machine of this kind, only on paper. His brainchild, dubbed the analytical engine, would comprise a processor, a control unit, and input and output device. However, this project was not implemented. It was not until his friend Ada Byrom, who later became known under the surname of Lovelace, created the first ever computer program for the machine designed by Babbage. The program was algorithm based and, if implemented, would be able to calculate Bernoulli's number. She is considered the first programmer, and she coined such terms as cell and cycle. Why we need a programming language? Or what is the purpose of this programming language? Actually, the programming language enables us to write efficient programs and develop online solutions such as mobile application, web application, and games, etc. Programming is used to automate, maintain, assemble, measure, and interpret the processing of the data and information. Why do we have so many languages? Because different languages are designed to be used for different purposes. Some are useful for web development, others useful for writing desktop software, others useful for solving scientific and numerical problems, and so on. We all know a computer can only understand two distinct types of data, on and off. In fact, a computer is really just a collection of on or off switches. Anything that a computer can do is nothing more than a unique combination of some transistors turned on and some transistors turned off. Binary code is the representation of these combinations as ones and zeros, where each digit represents one transistor. Binary code is grouped into bytes, groups of 8 digits representing 8 transistors. For example, 11101001. Modern computers contain millions of, even billions of transistors, which means an unimaginable large number of combinations. But one problem arises here. To be able to write a computer program by typing out billions of ones and zeros would require superhuman brain power. And even then, it would probably take you a lifetime or two to write. Programming languages are of different types and levels. Those levels are binary code, machine language, assembly language, high-level language, and scripting language. The system or the computer can only understand low-level language, but we users only knows high-level language. Then how is it possible to make both system and user to understand the language at the same time? That is only possible through compiler, interpreter, and assembler. These three helps in translating a high-level language to low-level language. The three softwares, compiler, interpreter, and assembler, does the same job, that they converts high-level language program into machine language. But in a compiler, it converts the whole high-level language program to machine language at a time. It is mostly used by C and C++. But in an interpreter, it converts high-level language program to machine language by line. It is used by Ruby, Perl, Python, and PHP. In an assembler, it converts assembly language program to machine language. It is mostly used by assembly language.